So let's recreate our programming model diagram. We've got threads, and we've got thread blocks. And really what is happening with these barriers is that the sync threads call is creating a barrier within a thread block. So all the threads within this thread block are going to get to this sync threads call, stop, and wait until they've all arrived, and then proceed. And these thread blocks are organized in kernels. Every kernel has a bunch of thread blocks. We haven't talked about this really, but there's an implicit barrier between kernels. So if I launch two kernels, one after another, then by default, kernel A will finish before kernel B is allowed to start. So all of these threads will complete before any of these threads get launched. So when you add in our memory model that we've talked about, where every thread has access to its own local memory, to its block's shared memory, and to the global memory shared by all threads and all kernels in the system, then what you've got is CUDA. At its heart, CUDA is a hierarchy of computation. That would be the threads, thread blocks, and kernels, with a corresponding hierarchy of memory spaces, local, shared, and global, and synchronization primitives, sync threads barriers, and the implicit barrier in between two synchronous kernels.